students, welcome to the series of CAT questions. How many of the integer from 1 to 120 are divisible by none of 257? That I don't want any multiples of 257. I have total 1 to 120 integers available. Fine. So with method 1, remove all the multiples of 2 from the given numbers. So I will be left with odd numbers. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Last row would be 1, 1, 1, 1, 1, 3, 1, 1, 5, 1, 1, 7, 1, 1, 9. So I would be left with these many integers. So I had in total 120 integers. I have removed all integers that are multiple of 2, that are even numbers. So 60 are removed. I am left with 60 numbers. Now my next agenda would be to remove all the multiples from these numbers which are divisible by 5. So this column would be gone. 0, 5, 1, 5, 2, 5 till 115. So in total I would have total 12 multiples of 5. So I would straight away deduct them and would be left with 48 multiples. Then next agenda is very simple. I have removed multiple of 2, multiples of 5. Now I have to remove multiples of 7. So I will check out of these numbers which one are multiples of 7? 7. Even multiples I have already removed. Even multiples of 7, that is 14. Then 21, this has to be removed. 28, 35, 42, 49 to be removed. 56, 63, 70, 77, 84, 91, 98, 105. So how many multiples of 7s are to be removed? 1, 2, 3, 4, 5, 6, 7. So 48 minus 7. So my answer would be 41. When I remove all the multiples of 2, 5 and 7, so I would be left with 41 numbers. Clear? So let's solve this question with another method. 7 into 17. 7 into 17 is 119. So in total I have 17 multiples, right? There you may have a doubt. There would be some multiples which are common to 2 and 5. For example, 10. So 10 would be counted once while counting multiple of 2 and once while counting multiple of 5. So I will have to remove them. So these are the direct multiples. Now I will be taking the common multiples and removing them. Multiples of 2 and 5. Smallest such multiple would be 10. 10 into 1 and last would be 10 into 12. So in total I have 12 such multiples. Similarly, 5 into 7 I will have smallest such number would be 35. 35 into 1, 35 into 2, 35 into 3, 105. Fine. So in total I have 3 multiples. Next, 2 and 7. Common multiples of 2 and 7. Smallest such multiple would be 2 into 7, 14. First would be 14 into 1, 14 into 2. So 14 into 8, 112. So this is the total number of multiples which are of 2 and 7. Lastly, I will be finding some numbers which are multiple of 2, multiple of 5 and multiple of 7. What would be the smallest such number? 2 into 5, 10. 10 into 7, 70. 70 into 1, 70. 70 into 2, 140 goes beyond. So I have one such integer. I can relate this to the set theory, as in I have total 120 integers. Few of them would be multiple of 2. Another set would be multiple of 5. Last set would be multiple of 7. So I have added multiple of 2, 5 and 7. In the first set, I will be adding these three numbers. Then this particular portion, the integers which are multiple of 2 as well as 5 would be counted twice, once in both circle. So I would be removing it once. Same way, multiple of 5 and 7. Same way, multiples of 2 and 7. These have to be removed once. So if I consider this particular area, this was counted thrice and removed thrice. So I will have to add it once. So in total, what is the summation? 84 and 17. 101, 12 plus 3, 15 and 8, 23, and this is 1. So 101 and 102 minus 23. So I would be left with 79 numbers. So out of 120, 79 are such numbers which are multiple of at least one of 2, 5 and 7. So if I want the numbers which are multiple of none of 2 and 5, 7, those numbers will be total number minus multiple of at least 1, 41, same answer, right? So let's try to even optimize this method. This was a method related to set theory. How do I optimize? Let's say I have in total 120 multiples. I want to remove the multiples of 2. Straight away I can say that half the numbers will be multiple of 2. So 120 by 2, 60. So I directly got this number. Next, multiple of 5. Every fifth number will be multiple of 5. So I will have total 24 multiples. Multiples of 7, I would have 120 divided by 7. So it would be 17 point something. I would take the integral number 17. Then straight away, multiple of 2 and 5, that is 10. So out of 120 number, every 10th number would be multiple of 10. So I will divide by 10. Again, multiple of 5 and 7 is 35. 35 into 2, 35 into 3. Here directly I can say. And multiple of 2 and 7, that is 14. 120 divided by 14. So if I divide, integral part would be 8. Lastly, multiple of 2 and 5 and 7, that is 70. 120 by 70, integral part would be 1. I have to add these three numbers, 84 and 70, 101. I will have to remove these three numbers, 15 and 8, 23, and add this number, 101, 102 minus 23. It should be 79. So answer would be 120 minus 79, that is 41. So what I achieved in this method 3, these calculations where I had to do complete calculations to find out how many numbers are multiple. Here in the last method I directly divided by particular digits to get the total number of multiples. Hope this is clear. Thank you.